Hey, hello all. This is Georgios in the second part of quality assurance engineering for artificial intelligence, for AI. And yeah, and again, of course, when you're gonna see all of these slides, you're gonna, think that I already have a data scientists. I have a team of data scientists, and they are responsible for all of these little things that we're gonna mention. But this used to be the same thing for in the past. You had only software engineers, and you were saying that software engineers are responsible for the quality. But QAs are dedicated for that, for the quality. For example, in this case, for the training data. And we have this funny quote here that who are these people browsing through the data all day? This thing that in data scientists know and machine learning engineers know, it's like look at the data. But they have so many other things in their plate, especially these kinds of people. They're scientists. They have to read, the new technologies, study them, experiment. They don't have only a small portion of the day will be spent on looking at the data. And this is where, in various aspects, QAs will come in to help with that. Let me remove this to the side so you can hear this more clearly. So, ensure that after all pre-processing, the final training data rows correspond to the same outputs as the original data. No confusions, etc. So you understand here that when you're gonna get the original data, whatever data you're gonna gather, there's gonna be a lot of pre-processing before any kind of machine learning model that requires only numbers and requires more clean kind of data. This machine learning model will want a good quality of training data because in data science, garbage out. So you don't want to put garbage in. And usually you have a lot of pre-processing. And especially if you're gonna remove rows and or reorder rows, perhaps something is gonna go wrong. And let's look at this small example. Uh, so you have a very very simple example here. They have like the input and the output, and here you're gonna want to pre-process it and have the input like so. And ideally, you want the same output, but you should here the output is shifted. Like 36 and 100 and 400 has been moved towards the bottom, and we have a 0 here. And imagine that this was a huge table of data, and you have just put output on the side to concatenate again later. But what happened is that, some mix up, you have your new input, but corresponds to a totally different output. So basically, here you're saying to the machine learning model that if you see this input 6, expect output 0. If you see input 10, you expect output 36. So basically, the machine learning model is being trained on the wrong stuff, and it will not understand that this is the wrong stuff. You need to you need to be sure that the training data, the input and the output correspond to actual useful data for the model that you want to build. And again, like in every point here, how QA can help here is actually put perhaps some ideas, merely observe them, just look at that. Because again, this was just an observation, that a human, for example, can easily do here. Or that somehow from the script you can deduct that these new inputs here really correspond to these outputs. Uh, this could be, a QA engineering task, but the point is to somehow not confuse the data. You can even confuse, the inputs, right? And have one column of the inputs be totally different from another column. So your instances are mixed up, and you don't want this to happen. Another thing that QA can help: you train data and sum them by eye to see if they make sense. And here some some things that as examples: a model trained to predict housing prices using data that contains outliers. Okay, so you have housing prices, and there are outliers inside, and the data contains housing prices that are significantly higher or lower than the typical prices in the area. Again, supposedly, you have gathered your data, but you know the data might be shifted. Something might have happened inside this area the past year, and data that you previously thought that were okay, now they are not. A person can browse online and see, and just observe and confirm that these prices are the price that you want. And a model trained to predict loan default using data that is not representative of the population. The data containing mostly instances of individuals who are white, male, but the population of interest also includes individuals who are female, right? Or from other ethnic groups. So again, here you want to predict that a bank loan, will default, and you don't want to include only. This is also false in biases that we're gonna talk a little bit afterwards. But the point is, like, what you can do here just by merely observing things, right? And you might observe that something is that some of the data are full of zeros that a machine learning model might not, or an automated method might miss, because the zeros are only a few instances of them. Anyway, like building some, like get acquainted with the training data a bit more than the data scientist has the leisure to do. It will bring value to the model for sure. Ensure features are sane, numerical, and within the expected range after cleaning. So here, um, you want some data engineers are cleaning the data, and they have their pipelines. They have built their in Python or other programming languages some a lot of functions that will be applied on this data, maybe to make them numerical, categorical, take the categories and make them into numbers as well. And this is a lot of code, and things can go wrong. And you want, a lot of code. This is synonymous with software QA engineers, right? And let's look at that. So, for example, you want to see that, the age here has a 54 and not a number or a -10. You might have your model just use those. The model will be trained on a -10 age, which doesn't make sense. Or there are some algorithms out there that will take those neutral, good, and low, and that you have set here as a customer satisfaction, as a feature, right? You have the customer satisfaction, and there are some models that will actually accept strings like that, and you might have missed it. You might want to do your own pre-processing and have neutral be zero, good be for example plus 10, and low be plus -1 or something like that. But the point is that if you let it to some algorithm out there, you might take those three strings and other things that it might see, and just put silly numbers like dummy numbers like 0, 1, 2, and then supposedly this is going to work. You're going to have the final output, but it was trained on something that it was not yours. It was not. You didn't help it to be to shift it towards the direction you wanted to give meaning to this customer satisfaction. Then you have the temperature. You know, the temperature here. You might think that this is okay, but actually all of those are not expressed. You might expect Celsius, but they might not be Celsius actually. Um, so other things that the QA engineers can help ensure that the sources being used as training data are the same ones that were agreed by business and senior data scientists, right? Um, and this is now is talking about the sources. So because anything can be converted into numbers eventually, but the point is like if the business or the senior data scientist they wanted to use those kinds of data, they have their regions, and they might decide to have lots of sources. So imagine that you want your machine learning model to get text from the internet, but this might be specified in various categories, in many. Maybe it's 100 categories, and uh, you don't want some of the sources to be missed. First of all, because it was not in the requirements, right? The requirements were to have those specific sources, and you don't want to miss any of those. Second of all, is because you're gonna train a different machine learning model, and this would not be good either. So let's have a couple of other examples here. And you want to predict the flight delays of airplanes. Like imagine now, right? Imagine that you would put the maintenance history of each airplane. That would cause a like merely. First of all, this data can be leaked, so it's like a security issue because you have a maintenance history of this airplane, and this might reveal if you share those kind of data or if you somehow you have them, you might get attacked by airplane companies of actually using them. This data might have been given to you for only for research purposes, but if you actually use them, you can better predict the flight delays because maintenance means that some things need to be done before the flight, extra things. But this can be very risky because those data might reveal that an entire company that has a fleet of airplanes, of aircrafts, is not going so well. So if those data are leaked, this is not good. And if these data are used, so if the predictions were very much better in comparison to other models, then you would be also exposed. Things to be considered, right? Another similar thing, you want to predict the outcome of next elections. Imagine if the model decides and has has put strong, um, you make the model be based on race, religion, sexual orientation, and the voters, as being treated like so. Again, um, the business here needs to decide it wants to use those kind of demographics to predict the next elections. Because if the model is a little bit biased or a little bit, for some reason, it's a black box, right? You use neural networks and stuff like that. You might find heavy weights for some peculiar reason that might not be easily explained towards some religion, right? And the next elections can be predicted depending on the religion of a person. Uh, Again, these sources need to be, the QA can come here and check those resources and certify that, ensure that the sources are being the training sources of the training data are those that we wanted them to be and not something different, right? And then you have ensure data the necessary variety, and sorry, ensure that data has the necessary variety to avoid biases. And biases, one example here is that AI can be used to analyze medical images, predict patient outcomes, and assist with drug discovery. Okay, we know this. It has already been applied to predict for cancer cases and I believe more and more cases nowadays. And and the point is, like, imagine here, you had all of this, and and here you want to actually include a variety. Imagine if you train your your algorithm that will help doctors take medical decisions, right? It will not, fully decide. Hopefully not. A law will prevent that, but uh, having, imagine that you take people from a certain country, only from a certain location, and this is biased, the biased model. Or imagine that the people being used for the medical training data, it's all people are tall. For some reason, just because you had this kind of data available, you're gonna use only tall people, and this might, the tall people might have different bone characteristics than other people, or in general, you might exclude, and then for you might try to apply this AI model to people who are not tall, and this might give you, totally weird results, or just results that are not useful, and the doctor will not find them useful, and thus your AI model that you spend months developing will be deemed as useless, and then you didn't achieve your business goals. So I'm here, referring some of those, like heart rate, and even something that needs to be taken into account. In general, try a variety to avoid biases. The the if you think about it, even an actual doctor that is viewing, patients, he's in he's gonna view various pages. But what happens if he has never seen, some patients who are from Australia, for example, and those patients might have some those perhaps indigenous people who have some different characteristics, and He doesn't know. So his model, what he has built in his head of what needs to be done, might not be. Or take another example: people from Tibet that they are in very high altitudes. The doctor might not be aware of what is specific for those people. So the same will happen to the AI, right? If you don't have a variety, you will not be trained properly. Ensure that after cleaning, an enough large data set has remained, that the training data being collected are enough to build a useful model. Of course, the enough will be determined by the data scientist eventually. The point is for the QA here to help ensure that the enough is respected. This is the whole point here, that you because you start and you consider that you have perhaps millions of data, but let's see our examples here. Again, medical imaging, you have a lot of artifacts. You're removing things that you have a lot of artifacts, and then you're left with very, very, very few useful images. Can you train on those? I mean, is it your training data large enough to actually consider building an AI model on top of this data? Or through all of this cleaning, you have left with so much little data that are not enough? Or in general, in thinking about volume, right? Natural language understanding. We have seen amazing AI algorithms lately in voice recognition, in translation, in chatbots, etc. But all this in English. What happens in other, like Kurdish, or some language that's being spoken by indigenous people, for example. Not all languages have the same content, right? Some have very little content, and is it enough to train on them, or are you gonna think that you be able to build, a good enough chatbot, but eventually you will not, just because of the training data being of small volume. And another thing that QA can help is ensuring that the training data represent the target's output in as much the same portion as possible. And here, imagine that you're classifying a music genre, but you mainly have rock songs, right? Eventually, like, you have a huge variety of songs, but then you really realize that you have from all varieties, but the rock songs are so much represented more than the rest of. And again, here, this is for data scientists to actually build those AI models that have, for example, think, like you have this difference in distributions, right? That you have very small from one data set, from one kind in data set, and a lot of from another. So what happens there is that there are some various ways for data scientists to deal with that. The point is that mm, the AI models will work better if you have some balance. The portions are similar. And this means that you're training your AI model, and you're spending time on training the AI model, a little bit from this, a little bit from that, a little bit from the other. Therefore, the AI model will be equally trained, let's say. And it's better, and you will build a better model if you can ensure that. And the QA can help, actually measure those, and create scripts, for example, to measure those balances. Another example here is noise cancelling using Imagine here that the AI is trained not only maybe here someone could say like mainly indoors and rarely outdoors. And, and the point here is to have this again, you might be thinking of biases, but here we're talking about the the actual output and targets. And another thing, and the final thing for this presentation is that to ensure that data has been standardized, um, I'm saying here you have the typical standardization, remove mean, and subtract by standard deviation to remove scale. And indeed, those are typical standardization processes before applying them to any model. But you also to consider other kinds of standardizations apart from the obvious, which is that here the house prices, we discussed about outliers, but here the differences are huge, just to make an example. But imagine that they were not huge. Imagine that there could be, for example, in be like it could be like something like that. And why is that? So you would remove this as an outlier, and maybe perhaps you would remove this also as an outlier. But what will happen with the rest? I mean, so this is the actual price, and this is the wrong price because those are not the term like these are not from the same currency. Here are all supposedly let's consider. I mean that all of them are of the same like euros, or all of them are expressed in dollars, and you want to actually as a QA, first of all have the processes in place to express that we have these kinds of features. For example, here we have square meters. I mean, we selected house prices of 100 square meters. Are we sure that all of the instances are actually from square meters? And these prices are all expressed in euros. First of all, the processes are gonna ensure that. And secondly, some kind of scripts, perhaps, again, that will be able to automatically assess that. So you have here, and all of this time we're just talking about training data, right? Um, if you see all examples that we brought here is about training data, haven't even touched testing data yet. We're talking about uh, how you can have the best kind of data prepared and ensure that it is like you imagine it to be. And the QA will be there to help both as humans that have built some domain knowledge on the data, and they can assess them manually, but also build scripts that will help the training data to be as good as possible. So thanks a lot. This was George Pligoropoulos. This is my LinkedIn if you want to know a bit more about the second part of the QA for AI, and hopefully we'll see you at the next one. Many thanks for your time.